begin our home page from pages 506 and 507 only. Home page pages 506, 507. Okay. Oh, sorry. Our objective for today, I can write and graph radical functions. I can write and graph radical functions. Last week we started with some of the graphing. I'm going to revisit that today just to make sure we got it. But today, just to remind us, what is the definition of radical functions? Tell your neighbor, definition of radical functions. What is it? Radical functions are blah, 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 blah. Some of you are like, oh, radical functions are my favorite. Yeah, that's not a definition. Yeah. All right, let's see. Good conversation between you guys. I think Roman can enlighten us with the definition. Roman. Very good. An equation whose rule contains a variable under the radical. That is correct. An equation whose rule contains a variable under the radical symbol. All right. So we know what they are. So last week, we did a quick review on functions and the graphs and what they look like. And we said that this is the original one, and then from there we have transformations that happen to the function. Is that correct? Yes, Mr. Q. And then we got to these, and I said this one, like I said, the original parent function always starts with 0, 0, 1, 1, and 4, 2. And I said those never change. Is that correct? Yes, and then I said, this has a transformation going on, and we said that it has a transformation of 2 to the right and 3 up. So this would be, this one would go 2 to the right, 3 up. This one, 2 to the right, 3 up. This one, 2 to the right, and 3 up. And my new function would be right third. You guys remember those? Yes? You're like, yes, these are my favorites. All right, good. All right, so with that said, lock your toolbar. I want you to graph me that one on your screen. You got 30 seconds. First, graph the original square root of x, and then from there, graph the transformation in red. Copy that and go. So here's the correct transformation. The original is here in black, and then the new one is in red right there. Okay. Yeah, we got it? That's nice of you. All right, good. Man, these are good, right? Yeah? Okay. All right, so we're going to do a quick exploration activity and see all the components of the transformations for radicals. Let me go to that screen. All right, so right now on your screen, you should see the new screen. Oh, thank you. You should see a new screen that takes you to Desmos. Is that correct? All right, so let me give you a code for that. There's a code. Log in, please. And with that code, it's going to take you to a screen that's going to ask you a question at the top of the screen. I want you to answer the question on your paper. Do you need to copy the question? No. Do you need to answer the question? Yes. So make sure you copy the question. So now, for those of you that are joining us online, this is what it looks like. There it is. And the question at the top of the screen reads, what does h and k do to the graph of the function when positive, negative, or 0? So you that are viewing the video, answer the question. And with the code, you should be able to log on and move these levers so you can answer the question. But make sure you address all of them, positive, negative, and 0. Once you are done answering that, move on to the next window where it says next and answer the question at the top also. I'll give you some time. Ready? Go. All right, let's see how we did. I'm going to move your screen by now. Okay? So get the graph paper in front of you. Let's see if we got this. Let's see how well we did research on this. Okay? So I'm going to start with blue. With blue, I'm going to graph f of x equals square root of x. Now, what value did we say we always use for that one? 0, 0, 1, 1, 4, 2. Okay. Now, why are those always the same, Mr. Q? Because if we substitute 0 of x in here, what is square root of 0? 0. If we substitute 1 of x in here, what is square root of 1? 1. And if we substitute 4 of x in here, what is square root of 4? 2. That's why we always get 0, 0, 1, 1, 4, 2. Okay. So now, according to what you just did, you should know how to graph this next one. F of x in red equals to negative square root of x. Before you graph it, tell your neighbor what that one's going to do to the original function. What is that one going to do? All right. So let's see. What does that do to the original, Laisha? It's going to what? It's going to make it go to the left. Hands if you agree with that. Close. If the negative is outside with any function, let me repeat that again. With any function, let me repeat that one more time. Any function with a negative leading the whole function, it reflects it about the x-axis. So, if I reflect this down here, it's going to be 0, 0, 1, negative 1, and 4, negative 2. All right. I'm going to change colors to green. F of x equals square root of negative x. Talk it over to your neighbor. Let them know what's going to happen to the blue one according to this new transformations since you did the exploration. All right, let's see. Let me pick someone at random. How about Cindy? What does it do to the blue one according to this? Over the y-axis. That is correct. It's going to reflect over the y, so this is going to reflect this way. Hands if you got that. Yeah. All right. However, look up. Instead of writing one more function, I'm going to actually graph a new transformation. Look up. Here's my original. Look up, please. And I'm going to graph the new one, which is there. Graph it. Once you graph it, I want you to write it over here. Talk it over to your neighbor, see what it's going to look like in an equation format. All right, tell your neighbor the new function for this one right here. Cindy, pass someone. Victor, what's our new function? F of x what? Negative square root of negative x. Sounds if you got that. That is correct. Okay, we got this, yes? Yes, Mr. Q. All right, good. All right, so we got those. Turn your paper over, and I'm going to give you a function g of x equals, you know what? Let me just forward this really quick. This one. Example 5. It says graph and state the domain and range. We got g of x equals square root of 1/2 parentheses x minus 3. And then outside the radical, we have -1. All right. So I'm not going to graph the original parent function, which is the one we graph in blue. I'm going to get started with the vertex of this new one. Tell your neighbor the vertex of this new one, please. All right, let's see. What's our vertex for this one? 3. Oh, sorry, I forgot a parenthesis right. What is our vertex? 3, -1. That is correct. 3, -1. Here it is. All right. Now, doing some practice of what we did last week, to graph this using this is very similar to what we did on the warm-up with absolute values. This works as a what? Like a slope, is that correct? That means we go up 1 and 2 to the right. So from here I go up 1, 2 to the right, plot my point, and graph my function. There it is. All right. So now that we have that, they're asking us to state the domain and range. I'm going to use set notation. So here we go. I'm going to start with the domain. I'm going to do that in blue. Domain. Solution set of x such that, now check this out. The domain is all x values for that function. So if I was to highlight from left to right, I start highlighting. Remember that? Highlighting, highlighting. Tell me when I first intersect that function for the x value. About right there. So what is my first x value? 3. And it keeps going to what? Positive infinity. So if it starts at 3, that means my x has to be greater than or equal to 3. And that's all I need. Let me go with the domain. The range, I'm sorry. Range. Range. Solution set of g of x such that g of x, let's see, I'm going to go from the bottom to the top. If I start highlighting from the bottom, there you go. If I start highlighting from the bottom, tell me the first y value that I encounter. What is it? -1. So that means, and if the arrow goes that way and it continues growing, it continues going to what? Positive infinity. So this is g of x is greater than or equal to -1. We good with domains like that, is that correct? You're like, yeah, Mr. Q, this is a good review, but it's easy. All right, but here goes the curveball. What if I asked you on the final to find me the domain and range of this function, but without graphing? Writing utensils down, look up to the screen. Without the graph. There it is. Right, here's the graph. Look up. I'm going to show you something. Hopefully you see it. Here it goes. In order for me to find my domain, look at my function. Some of you already saw it. What do we do to this that at the end we end up with this? Talk it over to your neighbor. What do we do to this that at the end we end up with this? Let's see. Victor, pass someone. Danica, what do we do to this so that at the end we end up with this? Very close. X minus 3, she said equal to 0, but is this an equation? No, so we do what? Greater than or equal to 0, and then you solve and we end up with that. That is correct. You guys see that? Yes? All right. Now look up. Let me show you the range. Here we go. Here's my range. You guys see the range within there. Hey, never where you see it? Where do you see the range there, please? Good conversations, very good. G of X is right there, and my constant is over here. And all you have to do is what? Greater than or equal to. How are we doing? Good? All right. Good talking. Lock your toolbar. I want you to write my domain and range. Do not graph it, just domain and range. I already know that you know how to graph. I want to see the domain and range without the graph. Lock your toolbar. Send that in as soon as you have it. You got 30 seconds. Ready? Go. Oh, by the way, our example is 5q, and that is g of x equals square root of 1/3 times x plus 4, close parentheses, and -2 outside the radical. Copy that and go. Check your work. There it is. Correct answer on your screen. Hands if you got that. Yeah, we got this, yes? Yes, Mr. Q. All right. So, look at this next one. Look up. Don't copy this. I'm going to change it a little bit. Look up, please. So let's say I gave you this function, but I said, you know what? Never mind. I'm going to change it a little bit, and it's going to be -2. -2. And I'm going to graph it. First of all, what is our vertex? Tell your neighbor, vertex. 5, 1, yes? So here we go. 5, 1. All right. Now, if this was a regular function, I would go up 2 steps and 1 to the right. Is that correct? 2 steps up, 1 to the right. But this is not a regular one because it has a negative inside of the radical. Tell your neighbor what's going to happen now that it has a negative inside of the radical. Go 2 up and 1 to the left. That is correct. It's going to reflect about the y-axis, or it's going to reflect like this. Imagine there was a y-axis right there to the other side. How are we doing? You guys see it? Yes? All right. Let's see. On your graph, I want you to graph this one. G of x equals square root -2/3 parentheses x plus 3. And then let's do -4. Don't find the domain and range, just graph that. Graph it. All right, who went last? Danica, pass someone. Jasmine, vertex? -3 and -4. -3, -4, which is down there, okay? Up 2 and 3 to the left. Up 2, 3 to the left. That is correct. Bam. Let's go. Hands, have you got that? Yeah, we got this, yes? Yes, Mr. Q. All right, let's crank it up a notch. How about this one? Example 6. Copy this graph really quick. Hurry up on the new coordinate plane. This point is 1, negative 2, and this one is 0, negative 1, and just graph your function. However, the instructions are write the radical function given the graph. Write the radical function given the graph. All right, here we go. First things first. This is going to look pretty fast because we already did writing functions, but using, I remember when we got to the cubic function. You guys remember these? So first thing I'm going to write my general form. G of x equals a radical 1 over b, parentheses, x minus h, close parentheses, and outside the radical plus k. All right. Now that we have our form, the first thing I'm going to identify is the vertex. What is our vertex, everyone? It's right there. This is h and k. So what is h? 1. And what is k? Negative 2. Okay, so there's my vertex. I'm going to substitute those. 1 and negative 2. So what does that leave us with? A and b. To identify a and b, I need to choose another point. Do we have another point given? Yeah, this one. So what is that point? That point given is 0 of x and negative 1 of y, or z of x. Now that I have that, who remembers the two parts to solving for a and b? Who remembers? Very good. B plus h or a plus k. So in order for me to solve for b, I use this value, which is a 0, and I write b plus h equal to 0, but instead of h, what is h now? 1. So I write b plus 1 equal to 0, minus 1 minus 1, so b equals negative 1, and that goes right there. So how do I solve for a, Mr. Q? Well, we use the second value of that point, and I write a plus k equals negative 1. But what is k now, according to our vertex? Negative 2. Do you guys see that? So I write a minus 2 equals negative 1, so plus 2 plus 2, a equals 1. That goes right there. And I just write my function. Copy that, please. G of x equals 1 square root. What is 1 over negative 1? Negative 1. X minus 1 minus 2. And that's all it is. So hopefully for tonight, you're going to be graphing, identifying domain and range, and the last one, which is writing functions from a graph. All right, guys. Once again, hopefully it's on pages 506, 507 only. There is tutoring today. It's free. If I don't see you guys tomorrow. Bye. Have fun with your home play. Make it a family math night. Bam. Let's go.